Hello everyone and welcome to Pepcoding. I hope you all are extremely good. So today in this video we are going to discuss a new problem on graph, that is the 0 1 matrix, right? So in this problem we are given a binary matrix of m cross n size and we have to return the distance of the nearest 0 for each cell, right? So what we are given a binary matrix, which means that only zeros and ones are present in this matrix, right? So in the given matrix only zeros and ones present, right? So let's take the example of this matrix. Also it is given that the distance between two adjacent cells is 1, right? So distance between these two is 1, distance between these two is 1, distance between these two is also 1, right? Distance between these two is 1 and 1, right? So distance between this 0 and this 1 is 2, right? So we have to find the distance of nearest 0 for each cell. This means that we have to traverse the entire matrix, right? So let's move to this cell, right? Now we have to find the nearest 0. Now the nearest 0 of this cell is this 0 itself, right? So the answer for this cell must be 0. Now, why? Because we have to find the nearest 0. Now this cell is 0 itself. So the nearest 0 is, distance is 0, 0, right? So the answer for all the zeros is 0. That is the distance between the nearest 0 of all the zeros is 0, because the nearest zeros are the zeros itself, themselves, right? So here also the nearest 0 is this 0 only. So the distance is 0. For this also, for this also, for this also, right? So the answer for all the zeros must be 0, right? So we have to find the answer for ones only, right? So let's find the answer for this one. Now the nearest 0 of this one is, can be this, this or this. All these zeros are present at the same distance. Now distance between the two adjacent cells is 1. This means that the distance of nearest 0 for this one is 1, right? Next, let's find for this one. Now the nearest 0 for this one is this. The distance between these two cells is 1. So the answer for this is also 1. Next, the nearest 0 for this one is this 0, right? The distance between these two cells is 1. So the answer for this is also 1. Now let's find the distance for this one. This, right? Now the nearest 0 from this one is either this 0 or this 0. These two are present at the same distance from this cell, right? So this is present here. We can move like this, like this, like this, or like this, right? So for all the parts, the distance is 1 plus 1, right? Here also 1 plus 1, here also 1 plus 1, here also 1 plus 1. So the minimum distance is 2, right? So the nearest 0 from this one is present at a distance of 2, right? So we have to return this matrix, that is we have to find the distance of nearest 0 for each cell. Now we identified that the distance for all the zeros must be 0, right? So we have to find the distance for ones only, right? So we are going to traverse this matrix. When we find a 1, we have to find the answer, right? So what we can do, we can move in all the 4 directions, right? So we can use BFS, right? Breadth first search, right? So for this one, firstly for level 1, since BFS is applied on level, so for level 1, if we find a 0 in any of the directions, then that level is the answer for this one, right? So firstly we apply BFS on this level, on level 1. So here we find a 0 in level 1, so answer for this is 1. Next, right? Next for this one, when we apply BFS on level 1, we find a 0. So the answer for this one is also 1, right? Because we find a 0 in the first level of BFS, right? Here also the first level, when we apply BFS on first level, we find a 1, we find a 0, right? So the answer for this cell is also 1. Now for this one, when we apply BFS on the first level, we haven't find any 0, right? So we have to apply BFS on second level, right? When we apply BFS on second level, we find the 0. So the answer for this is 2. So whatever will be the level of BFS, if we find a 0 on that level must be the answer for that cell, right? So we have to apply BFS on each cell with which contain a 1, right? So the time complexity of this approach will be what? The number of ones, right? Into the complexity of BFS, that is big O V plus C, right? So the time complexity of this will be this, that is the number of ones into the time complexity of BFS. So is there any better approach present for this? Yes, there is. What is that approach? In that approach also we are going to use the BFS, right? We are doing what? We are going to use a queue and we will store the location of all the zeros in that queue, right? So these are the rows number and these are the column numbers, right? So let's traverse in this matrix. Since 0 is present here, so store this location, that is 0 0. Store the location of next 0, that is 0 1. Store the location of next 0, that is 0 2. Store the location of next 0, that is 1 0. The next 0 is present at 1 2, right? So store all these locations in a queue, right? Next, mark all the unvisited cells where 0 is not present to mark all the unvisited cells. Now we can either mark this by using Boolean array, right? Or we can simply mark these ones to -1. These -1 indicates that these cells are unvisited for now, right? So we have to do what? We have to apply BFS on all these locations, right? Firstly, we are going to apply BFS on this 0, right? So when we apply BFS, we will check if any unvisited cell is present here or not on this level of BFS or not. Since no unvisited cell is present here, so we'll move to the next cell, right? So we'll move here. Here we will check if any unvisited cell is present on this. So apply BFS. Since one unvisited cell is present here, so this 0 will help to fill this unvisited cell, right? So how? By adding 1 to its value, right? So 0 will add 1 to its value and update the value of this unvisited cell to that value, right? So this will update to 1 because 0 plus 1 is 1, right? Now no other unvisited cell is present for this 0, right? So we'll move to the next 0, right? Now we'll move to the next one. Also, when we update any of these cells, we have to store this location also, right? Why? Because it can be possible that this one will help to fill any of these unvisited cells, right? By adding 1 to its value, right? So we have to store the location of this cell also, right? Next, we'll move 0 to no unvisited cell is present in the neighbor of this, right? So remove this. Next we'll move to 1 0. Now one unvisited cell is present in this 0. Now this 0 will help to visit that unvisited cell by adding 1 to its value, right? Now 0 plus 1 is 1, so this cell is updated to 1, right? So this value is updated to 1. This is also 1. Now after updating this value, add this location also because it can be possible that this 1 will help to fill any of the unvisited cells, right? Next we move to the 1 0. Also one unvisited cell is present in the neighbor of this 0, right? So this 0 will help to fill this visit cell by adding 1 to its value. So this cell is updated to 1 and add this location to the queue, right? So we have visited, we apply BFS to the 0. Now is 1 2 1 2. Firstly it is 1 0. Now we have done it for 1 2 also, right? So we can see that all the ones present at a location, all the ones present at a location at a distance of 1 from all the nearest zeros are done now, right? Are filled now, right? We have found the distance of all the ones which are present at a distance of 1 from the nearest zero, right? So it can said that only the ones which are present at a distance of more than 1 are left out now, right? So we'll move to 1 1. Now at 1 1 we are going to apply BFS. So when BFS is applied to this, let me change the pen color. So when BFS is applied to this, one unvisited cell is there, right? So one will help to visit this, to fill this unvisited cell by adding 1 to its value. So this value becomes 2. So this 1 is updated to 2, right? And add this to the queue, right? So now this 1 1 is visited. Now we'll move to 2 0. In the neighbor of 2 0, all the cells are visited. In the neighbor of 2 2 also all the cells are visited. In the neighbor of 2 1 also all the cells are visited, right? So now our queue is empty. We have visited all the cells and we have found the distance of all the cells from nearest zero. So our answer is what? Here I'm only showing that this 0 is helping the unvisited one to fill its value by adding 1 to its value, right? So our answer is this, right? So we are able to find the distance of all the cells from nearest zero by using the complexity of BFS only, right? So what we are doing, we are storing the location of all the zeros in a queue and we are applying the BFS on all the zeros instead of all the ones. So if if any of the unvisited cell is found in the neighbor of this zero, then this zero is helping to fill that unvisited cell by adding 1 to its value. Also, after updating the value, we are adding this location to the queue. Why? Because this is possible that this one is going to now help the any of the other unvisited cell to fill its value, right? So we are going to apply BFS on this also, right? So this is our approach. What we are going to do, we are taking a queue, we are adding the location of all the zeros and mark all other cells as unvisited. Next, all these zeros will help to fill all the unvisited cells. Will apply BFS on all the zeros, right? So this is taking a time complexity of BFS, that is big O of V plus A, right? So let's move to the code part now. So in the code, we are starting from traversing the entire matrix. So we are doing what? That we are traversing the entire matrix and we are storing the location of these zeros in a queue, right? So we have to take one queue. Now this queue is storing what? The row and as well as the column, right? So here we also need a pair class where we can store the row as well as column. So let's first create the class. Let's name this class as pair. Here one row is present and a column value is present, right? Next, let's create a constructor. Right, so this is our class, so we have to create a queue of this pair class, right? So we are going to implement this linked list as a queue, right? So queue is what? First in first out, right? So the element which is inserted first is the first which is to be going out, which is to be deleted out first, right? So let's name this as queue. So firstly we are traversing in the matrix. So let's traverse in this matrix. right? Since this is a 2D array, so we have to use two for loops. Now if 0 is present at any location, what we are doing, we are adding that pair to our queue, right? So if 0 is present, we are adding at last new pair, right? Row and the column, right? Else if any other value is present, we know that only ones are present, we are doing what, that we are marking them unvisited, right? Equal to, while replacing them with -1, right? Now this will do what, this will fill our queue up to this, right? Next we are doing what, that we are taking this pair, apply DFS to this, right? So in order to apply BFS, we can move in the 4 directions. So what we are going to do, we are taking a 2D array in which we are going to store the directions of all these 4 directions. So we can either move in, wait. So we can move either in the upward direction, upward direction, left direction, downward direction, and right direction. So here the dimensions are what, since we are decrementing the row, so -1 0. Here we are incrementing the column, so 0 1. Here we are incrementing the row, so 1 0. Here we are decrementing the column, so 0 -1. So we will create a 2D array like this, right? So we'll create a 2D array like this, and we'll traverse in this 2D array so that we can move in all the directions, right? So we'll move in the queue until the queue becomes empty, right? So we are taking a pair from this queue, right? So let the pair is pair, at the pair is remove, right? Since we are removing it, this is remove queue dot remove last, right? Remove first, right? Why? Because we are adding at the last and we are removing from the first. So this linked list will be will work as a queue, right? We are adding in the last. Suppose this is our linked list. We are adding in the last and we are removing from the first, right? So first element to be in is the first element to be out. Next element to be in is the next element to be out, right? So next we have to traverse in this direction array, right? And we have to traverse in this direction array. So firstly we have to create this direction array also. So let's firstly create this. Let's name this as direction. So there are 4 directions, either -1 0 or 1 0, right? Or 0 -1 or 0 1, right? So we'll traverse in this direction array. Right now the 0th index is storing the row value and the first index is storing the column value. So let's create a new row value and a new column value, right? So new row value will be the value where we are currently in, right? That is, now the row is representing by the R part, right? The R part of the pair, right? Plus 0th index, right? So this will give us the new row. Next, same for the column. Column is stored at the first index, right? So firstly it will move here. This will give us the new row, this will give us the new column, right? How? Suppose we are present at 0 0, right? So our next direction, our next location will be 0 0 plus minus 1 0. So our new row will be what? 0 plus 0th index of this, minus 1, that is minus 1, and our column will be 0 plus 0, that is 0. So our new location will be minus 1 0, that is in the top direction, right? Same for the column, right? But we have to check, is this move is right, that is if we are we not move in the out of this matrix, right? So if we take a this move from 0 0 minus 1 0, then we'll move out of this matrix. So we have to check these cases, right? So if new row is should be greater than equal to 0 and new column should be greater than equal to 0 and new row should be less than the length of the matrix, that is the number of total number of rows present, and it should be the column should be greater than the should be less than the total number of columns present, right? Right. Next, if this value, then we have to apply the BFS, right? So what we are going to do, so if we are moving here, if this cell is unvisited, then what we have to do, we have to fill this cell with the new value, that is this value of this plus 1, right? Otherwise we have to do nothing. And here we have to check this also, that if this cell is unvisited, that is matrix of the new row we have find and the new column we have find should be unvisited. Then what we have to do, fill this cell and new column with the value present at current cell plus 1. How? Here new row and these all these two directions are invalid. So when we move here we will check if this cell is unvisited. Let's suppose here minus 1 is present. So what we have to do, the value of this, right, the value of this will be updated to the value of this plus 1. So this will be updated to 1, right? So this is what we have to do here. We have done here, right? So we have updated this value, and in the queue also we have to add this value. The new pair with new row and new column. So this will go until our queue become empty, and in the end we have to return this updated matrix, that where each cell is representing the distance from the nearest 0, right? In the end return this updated matrix, right? So this is our code. I think this is correct. So let's try to run this. We are getting error that not a statement. Here it is int. We are taking integer array of direction, right? Silly mistake. Again, variable row. At 62. Here we are taking what the variable is, the row is what the value here. Here that the row is the, we are taking this pair in the rem variable. Now row is this value, the column is this value, right? So we have to put that here, dot r and dot c, right? So now let's try it. So we are getting the expected output. Let's try to submit it. So our code is passing all the test cases, right? So this is our code. What we are doing that if 0 is present in any of the cell, we are adding that location to our Q. Q is of what type? Pair type, where I is representing the, R is representing the row and C is representing the column. So we are adding the location of that cell to our Q, right? Else we are marking that cell as unvisited by replacing it with -1, right? Next we are doing what? We are taking the location of each 0 from this queue and we are applying BFS on that. That is in all the 4 directions, right? So we are taking a direction array which contain all the 4 directions. We are calculating the value of the new row and new column. If this value is valid, that if we are not moving outside of this matrix, then, and if that cell is unvisited, right? If the the value is -1, then we are replacing that value with the value of this cell plus 1. That is, this 0 is helping this 1 to fill its value, right? And we are adding that cell to the queue. Why? Because it is possible that this cell is now can help any other cell to mark its value, right? So after that we are returning from this, right? So I hope the concept is clear to you, that is how to find the nearest distance of all the cells from the zeros, right? So if you like the content, then give a like to this video. Thank you for watching.